Engineering Dynamics, Session 4, Kinematics of a Particle. Let's solve another problem in this topic. So we do have a particle which is located in a magnetic field from A to B. So that's A to B. And our particle located in the midpoint. So the total height is a 200 millimeters, and our particle is located at the center of this magnetic field and travels downward through a fluid medium from A to B. Mhm. If the particle is released from the rest at the midpoint C, so this is midpoint C, that's midpoint C. Mhm. We want to know what is the, and also acceleration. This time is a function of displacement. Mhm. Where S is in meters. Again, if this is a SI example, we want to determine the velocity of the particle when it reaches plate B, or S is equal to 100 millimeters, and the time of travel from center to the bottom B. Mhm. As soon as you categorize the acceleration, you can easily attempt the problem. So if you remember, VdV is equal to AdS. We already have the equation for acceleration. So integration from 0 to V of V times dV is equal to integration of 4s ds, which is the acceleration is 4s ds. So we just replace the acceleration in the formula. And if you integrate it, so definitely S is from a midpoint, which is 100 millimeters, that's a zero point 0.1 meter, to S. We don't know where it exactly reaches it barely reaches the ground. So if you do the equation, a half of V squared from 0 to V, it's a 4 over 2S squared from zero point 0.1 to S. And it just gives us a v function as a velocity as a function based off of displacement, and that's in terms of meter per seconds. Mhm. And definitely when s is equal to 200 millimeters, based on problem statement, it just gives us a downward velocity at b of equal to 0.346 meters per second downward. Mhm. As soon as we do have the velocity function to calculation of time, we do know ds is v times dt. So ds is the v, this is v times dt. And if you integrate both sides and take this part under ds, it just gives us ds over s squared minus the 1 point negative zero point zero 0.01 in parentheses squared is equal to a square root of that is equal to 2 times a 0 to t dt. Mhm. And if you do the math, it just gives you a note. Mhm. The integration of when you have a function, integrating a function of dx at numerator and a square root of x squared minus r squared at the denominator, which is exactly our case. This is x standing for x squared. Just show why the variable is s. That's not a big deal. Minus a constant, which is this part. That's a zero point 0.1 squared, which is raised to 1.01. And that's a logarithm. a normal logarithm of a open parenthesis x plus a square root of x to x squared minus a squared. So if you can uh, verify the similarity between these two integration, then our integration is a normal logarithm of ln of square root of s squared minus 0.1 plus a close square root plus s from point 1 to s is equal to 2t. Mhm. And if you replace that with the numeric value for a, if you do the ln or normal logarithm, it just gives you s squared minus 0.01 under square root plus s plus a this numeric value, which is normal logarithms of a point 0.1. Mhm. That's equal to 2t, 2 times time. At s is equal to zero point 0.2 meters, which is provided in problem statement. This is almost before hitting the ground. Before hitting the ground, it just gives t is equal to 0.658 second. That's the time which a particle travels in a magnetic field from the centroid to barely touches the ground. Mhm. Just pay attention. Note 1 was the integration formula. Note 2 is that the formula for constant acceleration again cannot be used because the acceleration change with the position. So A is a function of S. Mhm. Thank you. I think we are good for now. We'll solve more problem in next video and sessions. Thank you.